Hello everyone, welcome back to yet another day, a new session, a new topic. Like I told you that with operations management or the way the paper of operation management is laid out, we are at the fag end of the syllabus and we are moving into something called as optimization, where now everything is doing going on. There is no problem, no operation needs any kind of help. But what I'm trying to figure out now is, can things be done in a slightly better way if possible? Because when you do something better, when you do something more efficiently, you are utilizing resources better. When you utilize resources better, you spend less money, you spend less time, and you make more profit. And yet another topic that we are going to do under this section that we are going to do today is a transportation problem. What is a transportation problem? As literally as it sounds, literally, transportation problem. A problem where we are going to decide transporting something from one place to another. Now, because it's a topic where, like I told you, we are going to decide transporting things from one place to another, there isn't much to discuss here, like what simulation means or what does project management mean. I don't need to tell you that. It's as simple as that. You are transporting goods. So to understand this better, instead of dwelling on other examples, I'm just going to give you a straight example or a question that we are going to do and then continue. So let's look at questions. Well, the question says that a company has three factories, F1, F2 and F3. Okay, company with three factories which produce capacities of 11, 13 and 19 units in thousands. So I have three factories where I'm producing something. What am I producing? I don't know. Could be anything. Could be clothes, could be water bottles, could be pens, could be cars, could be trucks, could be anything. And factory F1 can produce or has a capacity of 11, F2 has a capacity of 13, while F3 has a capacity of 19 in thousands. So F1 has a capacity of 11,000, F2 of 13,000 and F3 of 19,000 units. Sorry. It has four warehouses, W1, W2, W3 and W4. What does this have? It has four warehouses. Well, what do I do with these warehouses? It has four warehouses with demands of 6, 10, 12 and 15. So I'm producing in a factory and then I'm sending it to a warehouse. There are three factories while there are four warehouses. Warehouse 1, warehouse 2, warehouse 3 and warehouse 4, which demand 6, 10, 12 and 15 units in thousands. So the warehouses have a demand of 6 units, 10 units, 12 units and 15 units respectively. Unit cost of transportation, very important. In transportation, whenever a cost is given to you, we are expecting a unit cost of transportation. How much does it cost you to transport one unit from one place to another is given for each factory to each warehouse. So factory to warehouse, the cost of transportation is given to you. Okay, what do you want me to do? Based on the information, construct a transportation table. Fine, let me write down the given data and then I will construct the transportation problem for you. So let me show you how I'm going to construct the problem. I have three factories and four warehouses. Okay. So when I construct a table, this is what I'm going to do. If I'm giving two lines for everything, then this is going to be the top to and from. Then this is going to be factory F1, factory F2, factory F3 and one extra. Why? I'll tell you why the one extra. This is going to be my vertical. Let's go horizontal. So now horizontally, I am going to do I have 4 warehouses, then draw 6 columns. I'll tell you why 6 columns. So, one, two, 3, 4, 5, and one more 6. Am I drawing crooked lines? Yes, a little. 6. So, if you have 3 factories, you will draw 5 rows. If you have 4 warehouses, you will draw 6 columns. You'll always draw 2 more than what you require. Done? Let's start filling it up. The first thing that I'm going to do is I'm going to draw a line here. And I'm going to say this is from and this is to. From factories F1, F2, F3 to warehouses W1, W2, W3 and W4. Let's write down the values and then I'll tell you what these values are. 42, 32, 50, 26, 34, 36, 28, 46, 64, 54, 36 and 82. Done? What does this mean? Well, what this means is that if I want to transport, what is this? This is per unit cost. If I want to transport from factory 1 to warehouse 1, if I am transporting 1 unit from factory number 1 to warehouse number 1, it is going to cost me 42 rupees per unit. But if I am going to transport 1 unit from factory 1 to warehouse 2, it is going to cost me 32 units, or I am going to end up paying 32 rupees per unit. If I am transporting from factory F1 to warehouse 3, it is going to cost me 50 rupees per unit. If I am going to transport from factory 1 to warehouse 4, it is going to cost me 26 units. And that is what this data is. Done? Remember I told you to leave 1 extra row and 1 extra column. Why is that for? Let's come back to the question. The top of the question says, the factories have capacities of 11, 13 and 19. So, factories have capacities. Just hold on for a second. Should I write with this? This is still blue. Do I have a black? Perfect. The factories, so F1, F2, F3 have capacities. What is the capacity? F1 has a capacity of 11. I don't think in a video you all can really tell the difference whether it is black or blue. Anyway, factory 1 has a capacity of 11,000. Factory 2 has a capacity of 13,000. And factory 3 has a capacity of 19,000 units. Similarly, warehouse W1, W2, W3 and W4 have demands. Correct? What are the demands? If the warehouses W1, W2, W3, W4 have demands of 6, 10, 12 and 15 units. So they have demands of 6, 10, 12 and 15. So W1 has a demand of 6, 10, 12, 15. I'm sorry, I'm terrible at this. Let me just check it once again. I have zero self-confidence. 6, 10, 12 and 15 units. Perfect. Done? So what do you have to do? Simple. You will produce at a factory, and from the factory, whatever article you produce has to go sit in the warehouse. From this warehouse, it will go to different dealers. Your job is to send it to the warehouse. Now, there are 3 factories and 4 warehouses. This is so stupid. If there are 3 factories, there should be 3 warehouses. No. Or if there are 4 warehouses, there should be 4 factories. Arey, why? Why is it important to have 3 factories and 3 warehouses? This is so stupid. What if 3 factories can supply to 10 warehouses? That's okay. There's nothing wrong with it. Just one thing. What are the capacities of F1, F2, F3? F1 makes 11, F2 13 and F3 19, which is a total of 11 plus 13 plus 19 is 43 units in total. Let's check if the demands of the warehouses is also 43, because if it is not, then that is wrong. See, I don't care how many factories and how many warehouses there are, but I know one thing, that demand should meet supply. If demand doesn't meet supply, then what's the point? If your factories are making more than required, or if your factories are making less than required, then it's a problem. Even if there are 10 warehouses, but my demand is meeting supply, then I don't care with how many warehouses you do this. So the total of my capacities is 43 units. Let's see what the total of my demand is. Total of your demand is 6 plus 10 plus 12 plus 15 is also 43. Can I say demand does meet supply? And that is all I care about. I don't care how, if you had one factory, whose capacity was 43 and 3 warehouses whose demands are 43, that also is okay. If you had 10 other factories and the total capacity was 43 and 4 warehouses have a demand of 43, that is also okay. I don't care how many factories and how many warehouses you have. All I care about is demand meeting supply. If demand does not meet supply, it's a problem. Demand meets supply. I don't care how many factories fulfill how many demands of how many warehouses, as far as demand is meeting supply. And this is a standard transportation problem or a transportation table. What will it have? Now here it is factories and warehouses. It's not always factories to warehouses. It could also be factories to stores. I'm producing in a factory and it is being sent to 4 different stores. So suppose I'm Tata and I'm making cars. So I'm producing in 3 different factories. Let's say one in Mumbai, one in Maharashtra, one in Gujarat, and let's say one in Punjab. And I'm transporting to 4 different states. And the cost per unit of transportation is being fabricated in the table. So what is this part? This is the cost of transportation per unit from the factory to the warehouse. This is the demands of the warehouses and this is the capacity of the factories. I don't care how many factories and how many warehouses you have. All I care about is the demands of the warehouses should be fulfilled by the capacities of the factories or the supply of the factories. If supply meets demand, I am sorted. And this is how a standard transportation problem looks like. What do you have to do? You have to tell your organization or you have to tell your transport manager who should transport where, so that everybody's capacities are exhausted and everybody's demand is fulfilled. That is it. That is all that you have to do in these questions. So what I'm going to do is, I'm going to leave this page as and how it is, and I'm going to prep solutions on a fresh page. So let me leave this aside and let me begin with a fresh page. There are different ways of solving a transportation problem. The first method of solving a transportation problem is called the north-west corner method. How does this method work? Well, for this method, I need a table. So that we don't waste time, I'm going to pause the video here. I'm going to get the table ready and then I'm going to show it to you. So, I have my table ready and I have written a few things in colors. So what I've done is, the cost I have written in pen, and the capacity and the demand I have written with a colored sketch pen, so that you understand the difference. Now this you can also do, but only for practice. When you're actually doing it in the exam, everything will be pen and pencil, that's it. No other color will be used. So you can't use like a multicolored pen, sorry. This is how it's going to be. What do you have to do? You have to supply from the factories to the warehouses such that all the factory capacities are over, which means all the supplies that the factories have are exhausted and the demands of the warehouses are fulfilled. The first method of doing this is called the northwest corner method. Now, I would want you to do this with me one step at a time, because at the end of this process, this entire table is going to be very dirty. So, if you do this with me one step at a time, it will become easier to understand. If you try to copy it after I have done it, not going to happen. You will have no idea what I have written in the table, because it's going to be very shabby at the end of this. I will try and keep it as clean as possible, but I don't guarantee. So, I would want you to do this with me. If you are doing this with me, this is what I want you to do. I want you to make sure that there is a little place on the right and the little place below the table. There are a few things that we have to write here and here. So make sure this place that I have, this much is enough. Let's begin then. The northwest corner method, as literally as it goes, the northwest corner method. If you are looking at a map, every map is set out in a certain way. What is the way? Every map when you look at is, the top of the map is north, then the bottom has to be south. If this is north, then this has to be the east and this has to be the west. Correct? Northwest corner. What do you mean by northwest corner? So when you look at the north and the west, the direction between them is the northwest corner. So basically, the left top corner is what we are looking at. What are we looking at? The left top corner is the northwest corner. What does the northwest corner say? Or northwest corner method say? The northwest corner method says, you see these cost cells, which means this grid. Go to the northwest corner of this grid. What do you mean by northwest corner? North is top, west is corner. So northwest corner. So here if you go to see, can I say this cell is the northwest corner? Yes. What is this cell? This cell is factory F1 supplying to warehouse W2 at a cost of 42 rupees per unit. I'll repeat. Go to the northwest corner. What is this? The northwest corner? The northmost and the westmost. So northwest corner, go to that corner first. And in that corner, which is F1 W1, first provide for this cell. What do you mean by this cell? Or first use this cell, which means first supply from F1 to W1. Okay, what do you need to check? You need to check what is the capacity of F1 and what is the demand of W1. Well, the capacity of the first factory is 11 units. I know in thousands, but 11. So the capacity of factory 1 is 11 units. And what is the demand of warehouse 1? Well, demand of warehouse 1 is 6 units. I repeat, F1 has a capacity of giving 11 units. How much does warehouse 1 need? 6 units. So, if factory F1 has a capacity of 11 units, can I say F1 can give all 11 units to W1? For what joy? W1 doesn't need 11 units. W1 is clearly saying that my demand is only 6 units. Okay, then why not you ask factory 1 to give 6 units to W1? But capacity is 11, that's okay. Keep the rest of the 5 units, we will see what to do of that. Or textbook method is, go to the northwest corner cell. This is the northwest corner cell. For that cell, examine demand and supply. So check what the demand and the supply is. The demand is 6 units while the supply is 11 units. Allocate whichever is less. What is less amongst the two? 6. Then I will give W1 6 units from F1. But I told you why practically 6. Because F1 can give 11, but W1 doesn't require 11. That is why you choose lesser out of the two. Suppose the cell I chose was not F1 W1, was this cell. Sorry, let's take this cell, was F1 W3. F1 has a capacity of 11 and W3 has a demand of 12. What will it give then? Will it give 12? Or you know, how can it give 12? I know you want 12. I know the demand is 12. But I have a capacity of only 11 units. I can't give you 12 units. That is why you allocate lesser out of the two. So I repeat, go to the northwest corner. This is the northwest corner. Examine the demand and the supply. 6 units and 11 units. Allocate whichever is less. What is less? 6 is less. Or in other words, even though F1 has a capacity of 11 units, W1 only needs 6 units. So I am going to give 6 units going from F1 to W1. So F1 to W1 is going to be an allocation of 6 units. Done. Now, if from F1 you have supplied 6 units to W1, can I say one thing? Can I say that W1 has all its capacities, all its demands fulfilled? It wanted 6 units. You are giving it 6 units from F1. At the same time, factory 1 had a capacity of 11, but it has decided to supply 6 units to W1. Then can I say it does not have a capacity of 11 anymore? Its capacity now has been reduced to 11 minus 6, which is 5 units. I'll repeat. Go to the northwest corner. In the northwest corner, examine the demand and the supply. Allocate whichever is less. Once you allocate whichever is less, reduce that value from the demand and the supply. How much have you allocated? 6 units. Then remove the 6 from demand and remove the 6 from supplies. So you have 0 demands left, and F1 has had a capacity of 11, has given 6 to W1, still has a capacity of 5 more units. Now you tell me, F1 still has 5 units of capacity left. W1 has no more demand left. If W1 has no more demand left, W1 does not have the right to stick in the game. W1 runs out of the game. I'm going to repeat this one last time. Listen carefully. Go to the northwest corner. examine demand and supply, allocate whichever is less, subtract that from the demand as well as the supply. One of them will always get exhausted. Whoever is lesser will always get exhausted. If the demand is exhausted, cancel out that column. If the supply is exhausted, cancel out that row. Sometimes both are exhausted. There are chances where, suppose if the capacity was also 6, I would give 6. This would also become 0. This would also become 0. I would cancel this column and cancel this row. So at least one will get exhausted or both will get exhausted. Either way, cancel whatever has exhausted, because if W1 has no more demands left, then what's the point in keeping W1 in the game? So I remove W1 from the game. Let me zoom in a little before I continue. Done? Now what? Go to the next respective northwest corner. So if this column is gone, then can I say this cost matrix is left? Now in this cost matrix, go to the next respective northwest corner. The next respective northwest corner, this 32, which is F1, W2. What do you do? Same. F1 has a capacity of 5 units. W2 requires 10 units. But I can't give you 10. I can give you 5. Is that okay? Yes, give me whatever you have. Extra I will take from somebody else. Okay. F1 has a capacity of 5 units left. W2 has a demand of 10 units. I can't give you 10, but I can give you this 5. Or in other words, allocate whichever is less. Once you allocate the 5 units, we realize that F1 gave 6 units to W1 and 5 units to W2. F1 has no more capacity left. W2 on the other hand required 10. You have given it 5 units from F1. So W2, 5 units done, 5 units still left. So demand of 5 units is fulfilled. A demand of 5 units is still pending. Now do you notice that F1 has no more capacities left? If F1 has no more capacities left, I will say that F1 is out of the game. Done? What do you do? Go to the next respective northwest corner. What is the next respective northwest corner? Well, this is the grid that is left. In this, the northwest corner is this 36, which is F2 to W2. What is F2 to W2? F2 has a capacity of 13 units, while W2 can only need, or W2 only needs 5. Why? 5 units already it is taking from F1. So it only needs 5 units. I don't need 13. Fine. Take the 5 from me. If F2 supplies 5 units to W2, W2 has no more demands left. F2 has given 5 units to W2. It still has 13 minus 5, which is 8 units pending with them. I now notice that W2 has no more demands left. Well, if W2 has no more demands left, then tell W2 to walk out of the game. We move to the next respective northwest corner. What is the next respective northwest corner? Well, these 4 cells left. The respective northwest corner is this 28. Correct? This 28 is for F2W3. F2 has a capacity of 8 units. Why? It had 13. No, yes, but it is giving 5 units to W2. So it has only 8 unit capacity left. And W3 has a demand of 12. Well, F2 will say, I can't give you 12. I have a capacity of 8. Take 8 from me. W3 will say, okay, give me the 8 units. Once F2 transports 8 units to W3, all the 8 units are gone, while W3 had a demand of 12 units. A demand of 8 has been fulfilled. What is pending is a 4 unit demand. What you realize is that F2 has no more capacity left. Then we say remove F2 from the game. What do? We move to the next respective northwest corner. What is the next respective northwest corner? This 36. This 36 is F3 W3. F3 has a capacity of 19 units. W3 has a demand of only 4. Well, you have 19. I don't require 19. All I need is 4 units. Okay, then do a thing. Take the 4 units from F3. So, from 4, when you remove 4, you are left with 0. And F3 had a capacity of 19 units. It has given 4 units to W3, which means now it does not have 19 units. It only has 15 units. Then can I say W3 has no more demands left? So we tell W3 that if you do not have demands left, move out of the game. What do? We move to the next respective northwest corner, which is just one, and that is 82, which is for F3W4. And because this is the last cell, you will notice something, that F3 has a capacity of 15 units and W4 also has a demand of 15 units. You know why this happens? Because demand meets supply. That is why every demand will be satisfied and everybody's supply will be exhausted. F3 has a capacity of 15 units. W4 has a demand of 15 units. So we give 15 units from F3 to W4. From 15, 15 gone, 0 left. From 15, all 15 gone, 0 left. Can I say that W4 has all its demands met? Then W4 moves out of the game. F3 has all its capacities exhausted. Then F3 also moves out of the game. Once that is done, my transportation is done. Remember I told you, pause this and do this with me one step at a time, because this is what happens. After this, if you say, oh, now I will copy, not going to happen. What do? Write down your answer by drawing a new table. I promise you one thing, at the end of this chapter, if nothing else, you will at least become an expert at drawing tables. So let me draw a new table and let me write down my final answer so that I can see it properly. So let me draw a table. I will fill in the details with you. Let me draw the table at least. Let's not waste time showing you drawing the table. So my basic table is ready. Let's unzoom a little so that we have both visible, legible together. Yes, fine. Let's start filling it up. So I'm still filling it up with a green pen. Eventually you have to do this with the same colored pen. So please, always, I prefer, so in this box that represents F1 to W1, I prefer writing the costs at the lower bottom and the allocation at the right upper corner. So from F1 to W1, 6 units. Okay, so 6 here. From, or you can do this with a pen. from F1 to W2, 5 units. Done. From F2 to W2, 5 units. F2 W2, 5 units. F2 W3, 8 units. F2 W3, 8 units. F3 W3, 4 units. F3 W4, 15 units. Done. Just cross check once and check if all demands and supplies are met. 6. Okay, W1's demand was 6. It is getting 6. W2, 5 from F1, 5 from F2, 10. Perfect. W3, 8 units from F2, 4 units from F3, 8 plus 4, 12. Fantastic. What about W4? Well, it needs 15 units and all the 15 units are coming from one place only. 50 are coming from one place only, F3. Fantastic. Let's look at the capacities. F1 had a capacity of 11. 6 units it is giving to W1. 5 units to W2. 5 plus 6 is 11. Sorted. F2 has a capacity of 13. 5 units it is giving to W2. 8 to W3. 5 plus 8 is 13. Fantastic. And lastly, F3 has a capacity of 19. 4 units it is giving to W3. 15 units it is giving to W4. 4 plus 15 is 19. That's it. That is going to be your answer. Now what we are going to do is, we are going to find out what is the cost of this allocation. And that is, number 1, from cost of, I would prefer writing it below, but I don't have the place. I want everything in one place, so that is why I'm writing it here. Cost of allocation. From F1, I am providing to W1, which is 42 into 6. 6 units at 42 rupees per unit. If you have a little more place to write, that will be nice. Put equal to and then write down what that value is. Then from F1, you are transporting to W2, that is at 32 rupees per unit, you are transporting 5 units. From F2 to W2, at 36 units, you are providing 5 units. From F2 to W3, at 28 rupees per unit, you are providing 8 units. And F3 to W3, at 36 rupees, you are providing 4 units. And at F3, W4, at 82 rupees, you are providing 15 units. Correct? Let's take a total. So I'm using the memory in the calculator to take a total. Make sure the memory is clear. 42 into 6. Add that to memory. You can write it on the right hand side here. I don't have place. Add that to memory. 32 into 5. Add that to memory. 36 into 5. Add that to memory. 28 into 8. Add that to memory. 36 into 4. Add that to memory. And 82 into 15. Add that to memory. Recall memory. The answer is 21. So the total cost of this transportation schedule is 2190. This solution that you see, or this allocation that you see, is called an IBFS. You know what an IBFS is? An IBFS is an initial basic feasible solution. What is this? It is an initial basic feasible solution. This is an IBFS. How did you find this IBFS? Well, I used a method. What is the method? The northwest corner method. Then this is the IBFS using the NWCM, also known as the northwest corner method. So above the table, I would write down that this is the IBFS using the northwest corner method. That's it. This is the answer that they are expecting. Obviously, this is very shabby. Nobody's going to get anything out of this. This is your solution, has to be shown. And after that comes this. This is the real solution that they are expecting. Transport 6 units from F1 to W1, 5 units from F1 to W2, transport 5 units from F2 to W2, 8 units from F2 to W3, and transport 4 units from F3 to W4 and 15 units from F3 to W4. The cost of this transportation schedule is 2190. Now in the same question, there are two more methods asked. I'm going to skip that. What I'm going to do is I'm going to go to the next question. I've given you one more question and I'm going to solve that question in the same method so that the northwest corner method fits into your head. And before that, I'm going to write down, this was my question, and just for the heck of it, this is not really required, but I'm going to write down IBFS using number 1, northwest corner method. What is the cost? The cost is rupees 2190. Done? Now the next question, like I said, I'm going to skip. Like the same question, they're expecting you to do the same transportation question with two different methods, two more methods. I'm going to skip that. I'm going to come to the next question and we are going to do the next question using the northwest corner method. So let's come to the next question. A company is transporting its units from 3 factories to 4 warehouses. Almost the same. 3 factories and 4 warehouses. There could be 3 factories and 3 warehouses, 5 factories and 4 warehouses, anything. That doesn't matter. What matters is, does demand meet supply? The supply and the demand of units with transportation cost per unit in rupees is given below. So see, they've given you everything in the question. Factories F1, F2, F3, what can they supply? And demand of W1, W2, W3 and what their demands are. And the cost per unit is also given to you of transportation. Based on the information, number 1, construct a transportation table and find the initial basic feasible solution. So find the IBFS using number 1, the northwest corner method or NWCM. Again, let me draw the question first or write the question down first. I have the question ready. Let's begin. So, this is the question that they have given us, and that is factory 1 to warehouse 1, 6 rupees per unit. Factory 1 to warehouse 2, 2 rupees per unit. Factory 1 to warehouse 3, 6 rupees per unit, and so on. The supplies are, factory 1 can supply 120, 2 can supply 95 units, 3 can supply 85 units. W1 has a demand of 50, W2 has a demand of 60, W3 has a demand of 90, and W4 has a demand of 100. Does demand meet supply? Yes. The total of the supply is 300 and the total of the demand is also 300. Then I don't care how many warehouses have you set up and how many factories have you set up. If you can fulfill the demands and supplies with 2 factories and 20 warehouses, I don't care. All I care about is demand meets supply. If demand meets supply, I am sorted. I can begin with the question. So we come to the first. And again, what are we going to do? We are going to find the IBFS using the northwest corner method, NWCM. What does NWCM say? NWCM says, start with the northwest corner first, fulfill that, and then continue. Okay. If you look at this cost matrix, what is the northwest corner? Well, this 6 is the northwest corner. Fine. This 6 is F1 W1. F1 can supply 120 units. W1 has a demand of only 50. Then will I take all 120? No. If the demand is only 150, if the demand is only 50, why will I take 120 units? So again, textbook definition, go to the northwest corner cell. In the northwest corner cell, examine demand and supply. The demand is 50 units and the supply is 120 units. Well, I only require 50, so I will only take 50. So take 50, leave out the rest. So from 50, if you give away all 50, can I say W1 has fulfilled all its demands? What about F1? Well, it has given away only 50. 120 minus 50, 70 units are still remaining to be given. But I realize that W1 has no more demands left. If W1 has no more demands left, you can tell W1 to leave the game. We go to the next respective northwest corner. What is the next respective northwest corner? Well, in these cost cells, in these 9 cost cells, the left top cell is the northwest corner cell. 2. F1 for W2. F1 can still supply 70 units. W2 only needs 60. I don't need 70, I only need 60. Then you will say, okay, don't take 70, take 60 from me. So you are going to decide to transport 60 units from F1 to W2. W2 had a demand of 60. All 60 units are provided. 60 minus 60 is 0. F1 on the other hand can supply 70 units. You have only taken 60, which means that there are 10 units still pending. In this process, I realized that all the demands of W2 are met and hence W2 runs out of the game. We go to the next respective northwest corner. The next respective northwest corner is this, which is F1 W3 at a cost of 6. F1 can transport 10 units or supply 10 units. W3 requires 90. I can't give you 90. I can supply 10. Okay. Give me those 10, the rest I will see. So you will give 10 units from F1 to W3. If you give 10 units from F1 to W3, out of 10, all the 10 gone, 0 left. From W3, whose demand was 90 units, 10 unit demand has been fulfilled, which means an 80 unit demand is still left to be fulfilled. What I realize is that factory F1 has no more supplies left to give anything to anyone. It has given 50 to W1, 60 to W2 and 10 to W3. 50 plus 60 is 110 plus another 10 is 120. All 120 units exhausted. So we say that F1 cannot supply anything to anyone anymore. F1 runs out of the game. We go to the next respective northwest corner. What is the next respective northwest corner? Well, the next respective northwest corner is this. F2 W3 at a cost of 2 rupees per unit. The transportation can be done. F2 W3. F2 can supply 95 units while W3 has a demand of 80 units. My demand is 80. If you have 95, I don't need 95. Fine. Take the 80 from me. I will figure what to do about my extra units. So you decide to transport 80 units from F2 to W3, which means that W3's 80 demand has been met. F2 could supply 95, out of which you have only given 80 to W3, which means that 95 minus 80, a 15 unit supply is still pending. Since W3 has no more demands left, we tell W3 that if you are done, all your demands are met, please leave the game, and W3 walks out of the game. We go to the next respective northwest corner. Who is the next respective northwest corner? Well, this 6 is the next respective northwest corner, which is F2 W4. F2 has a supply of 15 units. W4 has a demand of 100 units. I can't give you 100. I have only 15. Fine. Give me the 15 then. So F2 gives 15 units to W4. When F2 gives 15 units to W4, we realize that F2's supply has been exhausted. While F4 required 100, it got only 15. Well, that's okay. Out of 100, 15 units has been fulfilled, which means a demand of 85 is still pending. F2 has no more demands, no more supplies left. So we tell F2, if you have no more supplies left, do not wait back in the game. We throw F2 out of the game. We go to the next respective northwest corner, which is only one left. F3 W4. F3 has a supply of 85. W4 has a demand of 85. 85, 85. Fine then, give the 85. Since W4 had 85 unit demand, which is fulfilled, 85, 85, 0. F3 had an 85 unit capacity to supply, 85, 85 gone 0, which means W4 is done with its demands. Then W4 runs out of the game, and F3 is also done with its supply, and F3 runs out of the game. And that's it. This is my transportation schedule. Let me do one thing. Let me copy this down. So we move this up a little. What is this? This is IBFS, initial, basic, feasible, solution using NWCM, also known as North West Corner method. Correct? What have you decided? Well, according to the northwest corner method, I have decided this. From F1 to W1, I am giving away 50 units. From F1 to W2, 60 units. From F1 to W3 I am giving 10 units. From F2 to W3 I am transporting 80 units. From F2 to W4 I am transporting 15 units. From F3 to W4 I am transporting 85 units. Done? Yes. Before I start doing the cost calculation, let me check if this is correct or not. Let me check if all demands and all supplies have been met properly. Fine. F1, 50 to W1, 60 to W2 and 10 to W3 is a total of 50 plus 60 is 110 plus another 10 is 120. Perfect. F2, 80, 15, 95. F3, 85, 85. Perfect. W1, 50, W2, 60, W3, 10, 80, 90, W4, 15, 85, 100. Perfect. Fine. Then let's start doing the cost calculations. So I'm going to say cost of this transportation schedule is going to be from F1 you supply to W1. What are you supplying? At a cost of 6 rupees per unit, you are supplying 50 units. From F1 to W2, at a cost of 2 rupees per unit, you are supplying 60 units. From F1 to W3, at a cost of 6 rupees per unit, you are supplying 10 units. From F2 to W3, at a cost of 2 rupees per unit, you are supplying 80 units. From F2 to W4, at a cost of 6 rupees per unit, you are supplying 15 units. And lastly, from F3 to W4, at a cost of 16 rupees per unit, you are supplying 85 units. Let's quickly check what the costs are. 6 into 50 is 300. Add that to memory. 2 into 60, 120. Add that to memory. 6 into 10, 60. Add that to memory. 80 into 2, 160. Add that to memory. 6 into 15, 90. Add that to memory. And lastly, 16 into 85 is 1360. Add that to memory. Recall memory. The answer is 2090. So the cost of this transportation schedule is going to be 2090 rupees. And this is my IBFS using the northwest corner method. What I want to do for the time being is I want to stop right here and I want to discuss question papers with you. So let me discuss our past question papers with you. Let's come to our question papers. What are we looking for? We are looking for transportation. So transportation questions are basically questions that you will see having a lot of tables. Wherever there is a table, stop and check if it is a transportation question. Let me get my book ready where I'm writing down all of this. So again, I'm definitely not going to solve them and waste time. You are going to do that for homework. So let's begin The June 17 question paper, skip through the objectives, directly come to the descriptive. 2AB no, 3A no, 3B is done, 4A is done. Let me mark that. This was done under simulation. 4B is done. 5A is done under project management. 5B is done under maintenance management. So not asked. Fine then. This question paper not asked. No transportation has been asked. So 10. June 17 not asked. Let's move ahead. December 17. Descriptive 2AB, 3AB, 4A, B, 5A, B. No, not asked. This is done under maintenance management and this is done under network analysis. So can I say that question paper also not asked? Okay. December 17 also not asked. Let's move to the next one, and that is the June 18 paper. In the June 18 paper, 2AB no, 3AB no, 4A, oh it is a table but it is not a transportation question, it's an assignment problem question. So skip through it. 4B no, 5A is done, 5B is done under maintenance management and done. That's it. So can I say not asked? No transportation being asked in the June 18 paper as well. Let's go to the next, which is after June 18 comes the December 18 paper. So 2AB done, 3AB theory, 4A is a transportation question. What is given to you? Find the initial basic feasible solution by the northwest corner method, NWCM. This is the question. Factory 1. See, there are 4 factories and 4 warehouses. Do I care? No. All I care about is demand meeting supply, and it will meet. So if you check, let me check. The supplies are 150 plus 270 plus 370 plus 230 is 1020, and the demands are 210 plus 330 plus 260 plus 220. The answer is 1020, which means demand is meeting supply, and that is all I care about. I don't care about how many factories are supplying to how many warehouses. None of my business. You supplied with 3 factories or 10 factories. As far as demand is being met with supply is all I care about. And how many marks has this been asked for? So if you go down for AB, here, this is the marks for 4A, 6 marks. Imagine this for 6 marks. Has been asked for 6 marks. So let me make a note of it. And that is transportation. 1 question, 6 marks. What is it? It is IBFS using northwest corner method. Fantastic. Let's move on to the next question paper. In the next question paper, we have the June 19 paper. So 2A, no, 2B is done under layout, facility layout, 3AB. 4A is again an assignment problem question, so nothing that we can deal with now. 4B is a queuing theory question which is being done. 5A is a sequencing question done. 5B is a maintenance management question which has been done. So not asked. Put a dash there. Let's come to the last question paper, and that is the December 19 question paper. skip through everything. 2A theory, 2B is done, 3A is theory, 3B is done under productivity management, 4A is transportation. I have a feeling they haven't even changed the numbers here. I think they have. I don't know. Not sure. Anyway, find the initial basic feasible solution using the northwest corner method. Find the IBFS using NWCM. Factory 1 to 4, warehouse 1 to 4. Supplies, demands. Warehouse, factory. Sell entries are unit cost in rupees. So what will you give them? Well, you are going to, first let me make a note of this. How many marks has this been asked for? 4AB is being asked for 8 marks here. They've written the marks here itself. So has been asked for 8 marks. Fantastic. One question being asked for 8 marks. So one question, 8 marks. What is it? It's again the same. It is the IBFS using NWC. I'm not going to do it for you. I want you to do it. What are they expecting? Simple. They are expecting you to, number 1, write down your question. Now after that, if you want to do it below only. So this is my transportation problem. Below that, I will draw my first this table. So I will write down draw my table. If you want, you can say finding IBFS using northwest corner method. Do this, but this is shabby. Nobody will understand anything. So then on the next page or below that, if you have the space, you will definitely not have space. And please make sure you draw big tables. Don't draw like a one-line box in which one cost and then in the same corner, don't write the allocation. I always say this in every class of mine, and I'm going to say this now also on video. Don't save paper. Use the paper as much as you can. When you get married and you have kids, if you are short of notebooks, get in touch with me. I will buy them notebooks. Don't save these notebooks for them. Not of any use. For all you know, they might go completely digital. So use these notebooks as much as you can right now so that you can afford the digital for your kids later. So please don't act dingy and draw small tables in one corner. Even if it's shabby. Look at this. This is so beautiful. It is obviously not as beautiful as I am, but it's still trying to be beautiful. So draw the table. This is definitely going to cancel out everything. Then you draw a new table. But yes, for now, when you are practicing, use a multicolor pen. Don't use that in the exam, please. Everything has to be one color. Is that clear? So you will write down your question, which is construct your transportation table. After that, you are going to solve the IBFS, solve for the IBFS using northwest corner method. This is the answer to that, and this is the cost calculation. This is like the most important thing, the IBFS and the cost calculation. This is it. With this, the chapter transportation comes to a sweet end.